This is problem number 35 for chapter 11 on randomness. And it says a certain college estimates that the 3-score SAT total for students who apply to it for admission can be described by a normal model with a mean of 1570 and a standard deviation of 180. So I know I have an N 1570, 180. Admissions officers search the pile of envelopes, there's a pile of envelopes on the desk, opening them at random to look for 3 applicants with SAT totals over 1800. So I'm looking for 3 greater than 1800. How many envelopes do I think they will need to open? Well, interesting question. I'm trying to do a randomness. I'm trying to see, kind of a probability question. How many envelopes I think they're going to have to open. And I know from my work in the past that that usually means a certain percentage of them are going to satisfy our criteria, and a certain percentage of them are not going to satisfy our criteria. And when I find a certain percentage of them, say between 1 and 100%, I can allocate numbers, random numbers, and use my random number generator to kind of mimic those percentages. So for example, not in this case, but in like our basketball examples, when we had a 72% free throw shooter, the free throw shooter was going to hit 72% of her shots. I could say the numbers 1 to 72 represent a make, and the numbers 73 to 100 represent a miss. And that would enable me to run some random numbers and find out how many shots you would have to take to make 1 or to make 2, that kind of a thing. Now, we're not given percentages in this problem that we're doing right now. But we are given a normal model, and I can use a normal model to kind of calculate the percentages. So first, let's start off with rule number 1, make a picture, make a picture, make a picture. So I have my normal model, and I have 1570, let's make it look nice. 1570 is my mean, and then I'm going to make my 3 standard deviations to either side. And my standard deviation is 180, so this would be 1750, this would be 1930, and this would be 2110. And on going negative, I have 1390, I have 1210, and I have 1030. So I know that what I'm looking for are scores of 1800 and above. So that's going to fall somewhere in this spot right there. Well, but where is it going to fall? How do I know what percentage are going to be greater than 1800 and what percentage are going to be less than 1800? Well, how about if I go back to my z-scores? That's not a bad idea. Because if I know my z-scores, I can do my normal CDF with my left z and my right z, and that's going to give me my percentile. Remember that? So let's do it. In order to calculate my z-scores, I have to remember the formula. Z equals y minus y bar over s. I'm given that information. My y that I'm looking for is 1800. My y bar, let's look at the mean again, 1570. So y bar, 1570, and my standard deviation is 180. And when I plug that into my calculator, I got about 10.1%. So I think for purposes of this problem, I'm going to just round that off to about 10%. And that's acceptable if it's 0.1. I will tell you if you need some kind of a decimal. So 10% of the students that have applied are going to have SAT scores in this area here. Well, if 10% are going to have SAT scores above 1800, that means that 90% are going to have scores less. So I have 10% greater than and 90% less than. And that lends itself really nicely to a random model where I can say, I want to use the random numbers 1 through 10. And I can say the number 1 is, how do I do that? Is it a greater than, or that's a less than sign? Number 1 is 1800 or better, and 2 through 9 are 1800, well, let's say less than 1800. Less than 1800. Now, I know in many of the other examples, we would have used, say, the numbers 1 through 100, and we would say the numbers 1 through 10 are good, and the numbers 11 through 100 are bad. But since we have such a round number of 10%, 1 through 10 works just as well as 1 through 100. You can do it either way, but I think we would find it a little bit easier if we do 1 through 10. So if we do 1 through 10, now I need to say, well, how am I going to find my random numbers? So let's call it my calculator. Actually, let's make that go away for just a minute. Just adjust the size of this. So I'm going to call it my calculator, and I will clear it off. And I'm going to use my random number generator. So I'm going to go math, probability, 5, my random number generator, and I'm going to generate numbers between 1 and 10. And I know I want a lot of them, but I know that my screen can only fit a certain number. And I don't really feel like having the dot, dot, dot. So I'm like, if I put 9 here, and I ask for 9 of them at a time, you can see that some of my numbers with that dot, dot, dot right there are telling me that they're off the screen, and then I have to scroll, and that's kind of aggravating. So I see I can have 1, 2, 3, 4, 5. I can have 6 numbers there pretty easily. So I'm going to go math, probability. I'll do my random number generator. I'm going to go 1 through 10. And I'm going to ask for 6 numbers at a time. And hopefully they'll all fit. So how many times do I have to go through the pile of envelopes? How many envelopes do I have to pick before I actually... 10-minute bell. How many envelopes do I actually have to pick before I can get one that is a 1? Well, let's find out randomly. So I'm going to press... well, actually, before I get 3, because I need 3. So I need 3 before I'm successful. So I go enter 1 time, and I don't have any. So that's 6 so far that I've opened, and I don't have any. So I'll hit enter again. And that's another 6. I don't have any. That's 12. Oh, my goodness. That's 18, and I still don't have a single one. Wow. 4 times. That's 24. I still don't have one. Wow, that's another time. That's what's that? That's 30 times. I still don't have one. Well, finally I got one after 30, 31, 2, 3, 4, 35 times. So my first person came at number 35. That was my 35th envelope, and I opened up 36 envelopes so far. 36 envelopes so far, and I still only have 1. So let's just mark that 1. Okay. So let's keep going until we get our 3. I'm going to go enter again. There's another one. So that was 36. So 37, 38, 39, 40, 41 envelopes so far. So I'm going to just keep track here, and I have 2. Now I've had 42 envelopes I've opened up. 43, 44, 45, 46, 48 envelopes. 49, 50, 51, 52 envelopes. So my third one came on my 52nd envelope. So on that simulation that I just did, my first simulation, so if I was keeping track here, it took me 52 envelopes. Let's try a second simulation. And you know what I'm going to do, because it's easier to count by 5s than 6s. I'm going to change this. And I'm going to go, math, probability, 5, and I'm going to go 1, comma, 10, comma, I'm only going to have 5 numbers. It's easier to count that way for me. So I push enter. None after 5. None after 10. 15. On my 16th envelope, right there, I have my first one. So I'm making my second simulation. Here was my first simulation. My second simulation, I had my first one at 16. So now I have, that was my 16th envelope, 17, 18, 19. I've done 20 envelopes so far. 25. Oh, wow. I got 1 on my 26th, and I got 1 on my 27th. So I've done my 3, and I've got, that one only took me 27 tries. So you can see how this goes. I have to do this simulation a number of times. I mean, I would have to do it probably a good 20 times to get this done, at least to get some kind of a reasonable sense of how many envelopes it would take. But I don't want to sit here and do that 20 times. It would be very boring. But that's the methodology. Once I got my 20 times, what I would have done, let's say that my 20 times worked out to be, I'll put them in red here since I didn't really do them, but let's say it was 40 and 42, and then 18 and 17. So however many times I run my simulation, I want to find the average number of envelopes I would have had to open. So in this case, let's say that would be 6 simulations. So I would add these numbers up. I have to delete that. And I would go 52 plus 27 plus 40 plus 42 plus 18 plus 17. I'd add those up. I would divide by 6 because I have 1, 2, 3, 4, 5, 6 scores. So I'm going to divide that by 6. And it tells me that the average number of envelopes I would have had to open. So that was 196. And I divide by 6 tries. And that tells me 32.6 is the average number of envelopes I would have had to open. And that would be the solution to this problem.